You can see once you will open, this window will appear. So in order to create a new file like a sample space, like click a new project. So you will see there is no, so I say my first project. Okay, I need to change my path, so go for the PSCAD training. Okay, then click and okay. So here you say the my first project workspace will be opened, and also the this is under the sample case workspace. So I can also save my save my workspace, like save, sorry, not save as, save workspace as. So here say you can say that's my on if other than this, if I say my first project. Okay, so that now you can see this workspace will be replaced with my workspace. So in order to see the definitions of this, so because we have not written anything, so just on the within the my first project, so this is the empty diagram. So now in order to proceed with that, so I just posted two documents, like the one was the single phase document if I want to see the working of that network, and also about one about the three phase where I need to measure the average power, reactive power, as well as the power factor. So for that, so just I uh, go for the master library. So there are different components available. If you see the passive elements, sources, miscellaneous input output devices, then breakers, fault, and HVDC fact devices. So in this way you can go and then import, exports, transformer, machine, and then there are the digital blocks also available, then transmission lines, and then cables. So protection, logical parts, and all details are also there. You can check. Okay, start from the source. Just click on the source. Okay, once you will click on the source, so there are different sources with the explanations are there. So these are the ideal sources that we see, and these are single line diagram view, and here you can see three phase diagram view. So all these are in such a way displaced. So you can see the solar plate MPPT is also photovoltaic source associated. So if we just as a single line diagram, we can copy this also. So we will see this modeling. So now just for the control purpose, just I'm, or this is adding this three source with the resistance so that we can check. Just right click and copy this one by control C, and then go to my project space and then control V. So by pressing on R button, like R, click, it will be rotated. So here you say elements you can rotate directly. Just double click to set the properties. So here you can see different available, different options available where we need to add the parameters. So first we need to change the configurations. Like if I'm adding source one, it's mean this is, you can see voltage source. Then source impedance is R. Yes. Now this is very important. If we want to add a ideal source, we can add. But if we say the source is behind the basically resistance, so we can add this resistance also. Now source control is fixed and internal, external. So most of the time fixed. Whatever data we will add, that will be. So system is run on three phase 100 MVA base, and then this is the base voltage right now 230 kV. Okay, we are not changing the base frequency 6 years, and the input time constant that is involved with that, most of the time this is a default parameter that we use 0.05%. Okay, there is no need of zero impedance and other mean, yes, if we are modeling a synchronous generator, then we will add these information, mean the impedance branch is available or not. Okay, next, the impedance value we can set that yes impedance, and then single line, and then the source behind the source as the impedance. Most of the time we use this one. Now you will see automatically parameters will be added like impedance, that's is 1 ohm. Okay, we are not changing, so because we are modeling as a simple source here. Next, other than source, we need to add a sink, that is a load. Just go to master library, then here you can check, because you was in the source tab. Now you can go to the main tab and then click on the passive elements, so where you can take any RLC branch, like here, like this is RLC tune filter. So we can pick any resistive model like this one, or inductive. Yes, this is three-phase load. Okay, we can pick only one inductance. Control C and then Control V and press R. This will be rotated. Simple. Okay, we can add a reactive inductor also. This is Control C. So not a resistor also. We are making RL circuit here and then rotate. Simple. Okay, we can rotate this one and we can place here. Now next, okay, just for confirmation, I think you are my voice is clear to all of you, right?
Yes, Tahir, it's clear.
Yes.
Oh,
Yeah, it's clear. All good.
okay, great. So next move, in order to connect this diagram, so just go to wire mode and then click on this, and then again left click, you can turn and then click and then escape it. When you press escape button, then wire mode will be off, otherwise it will be continue. So then again, then go where you want to turn, then again left click and it will be back, then left click and then escape. Okay, now enter tools under components. So in order to check the ground, placed is a ground. In order to rotate the ground, just placed here. Okay, and similarly we can add. And now important thing is that if the circuit are okay, I mean I have not changed any value, so I place the default values. If the other modeling details are available, that will be under this tab. So if not, automatically this will be disabled. And most importantly, if you need the help of this particular component, you can directly press it, you will get, it will get you the input. Under configuration you said inductance, then real, and like basically the information. And similarly, if we say three-phase capacitive load, so all information will be here. So that's a I mean good feature of PSCAD. You can directly get the component exact parameterization of your components through the help module. Okay, other than modeling, because we need to measure these signals, measure these channels, so I will add some voltmeter and ammeter separately. Like I can add multimeter, so I want to add a ammeter here. So this is ammeter, just I have not connected, and this is a voltmeter. Okay, one more important thing, in order to measure the current and voltage, so we know that the meter is in series. So if I placed here, so this is a shorted, so mean line is shorter, so it will give you an error. So just mean if I say uh, I will show you this one how to get it. So I just added here. Okay, that's okay. I mean I have shorted the meter. So we will see there will be an error. So in order to plot the results, just get a channel link like in output channel. Okay, yes, output channel is available here. So most important thing, just click on this and signal name is IA, then that name must be matched with this signal if it is IA. Okay, and then we add a data label to get that value, like here through a wire mode we can connect to this and then escape. So now we need to give this name is also IA. So now what you have done, mean you are measuring this IA value and giving this IA value to the channel, output channel. That channel will basically measure. So similarly in EA, that is EA, just click on the voltage and then okay, go for the output channel again. That value must be the EA. Okay, that's okay. After that we can add data label here, that must be same EA. Mean name must be matched and then through wire mode we can connect. So little bit more hands-on is required in PSCAD other than I mean, like in other software. So we only perform, I mean just we just click on the simulation button and it's solved, and then okay, just go to save your project, then save project. So project is saved. Okay, that mean that after that we can add a control meters and graph to this signal. Just right click on this and go to graph meter and then add overlay graph with signal here. Okay, and similarly we can add right click and then add overlay graph with signal here. Okay, next we can add the control also meter also, mean add a as a oscilloscope and also most of the time. So but that we can add from control panel here, and then we can directly just press control and drag this to place here. And similarly we can place another control and then control. In order to place here quantity, just press control and click and then drag. If this is a, if this is a case like here, if this symbol is shown, it means that is added, otherwise it is cannot be added. So this is a basically variation of your control. So we can change those information is aware that the maximum display we can change it because 2 minus 2 to 2 is given here. So in this way we can, and also we can plot multiple things together, like in a single plot we can model measure this, like in this is IA, then I can drag in VA. So E and IA this. So similarly this is EA, and then just click and control and then drag here. So mean multiple quantities can be plotted on a single graph. Okay, so remember I have done one mistake here. What mistake? That is I have added uh, a meter on the line. So mean line is shorted. So I will just save my first project so that okay, now I will go for home and then run. So he said there is an error. So I will go to error and then I will see. So he say I mean there are errors in this branch meter. So similarly in this, so he said there's an error in the mismatched dimensions. Okay, so in this way basically we need to what we do, we need to measure in the correct fashion. So delete this wire and first place this one. Okay, and then go to click on wire and up to this and then escape. We know it is in series. Okay, then it is in wire. Okay, and then press escape. And similarly for this, you can delete this one and place here and then add an wire. Okay, then press escape. Now save your control S, like, and save your project, and then sorry, run your case. Okay, that okay, sorry. We can change tools and components, and then okay.
Hello.
I think he's lost or okay.
What happened?
Okay, sorry for the interruption. So it was due to internet. So now, can you see my screen?
Yeah.
Not yet? Okay, yes, yeah.
So that was due to the internet device was heated. So I just restarted my device and now it's okay. Okay, now you
No
can see
worries.
that. Sorry.
I said no worries, no worries. That's fine. Yeah.
Okay. Okay. Now you can see that we have simulated this and okay, Saad is also it. So okay. Yes,
Yeah,
sure. Please.
really noisy.
Okay, I can. Now it's okay, right?
No, no. There's some,
Now it's fine.
no, no. Really noisy.
Okay, I think now it's okay, right?
No.
No. Still no. Okay, I can check and just give me a second. Now please confirm it's okay.
Yeah, now it's okay.
Okay, good. Okay, now you can see we have added a meter and voltmeter in a correct fashion. We can see that, I mean, dimension is correct because we have added ground here, so we need to add voltmeter with the ground. So next important thing is that how we can scale this our graph. So okay, next just click on this and press R. When you will press R, there will be a range of, I mean, automatically it will be settled. I mean the values of your. So if I want to delete this current, like here, I mean I'm removing the parameters quantity. I'm dragging again back. So, sorry, just for the correct overlay graph with signal, and then I right click graph and overlay signal. Okay, next important thing is that in order to get the actual range of this, just press on the click and then press R. So automatically, if you want to change the scale of this X horizontal scale, just press X, and if you want to change, then you can press Y. Mean we can directly change the, sorry, click on this and then we can press Y, and here if we can set X, then we can, so mean if we press R, so it will give you actual value. So next important thing is that here if we press X, this is X, and if press Y, this is Y, and if press R, so it is actual day. So in this way the values goes, because this is RL circuits, just we are not interpreting our actual results. So what we are receiving basically, this is about the graphic interface, mean the we have added one source, a resistant and inductance, and the source value, and we see and we measure the value. So it here you can see the value goes, the one E is at higher 9.9, and then the current goes behind the minus in the minus value. Okay, the above value is the in the current. So in order to get more value, like here in IA, so if we can set different traces, like here most important thing is that if we click on the x-axis, we can change the x-axis values here, and then we can change the y-axis value here. So we can extend the range between this, and also we can just press control and then we can left click and we can highlight this one. Just we can zoom this one, I mean we can minimize this one, and similarly like here, here. So similarly if we press and then R, so again it will be back, so within the range. So here also we can zoom just here, so you can see that this is a 3-phase voltages. Okay, and then in this way. Okay, next important thing about, okay, we can just, okay, that's done. And next important thing about this, okay, next properties, we can minimize this graph. Yes, this one. Here you can see that we can add this in this range, and then we can use this X and Y button, sorry, this one, and then we can zoom in, zoom out here through using this button, and then we can make range within the plot, and then we can add this move if this case is again with the, if here, I mean this is a cursor available, so we can just make use of control and then we can expand, simple. So again we can press, if we have just back and then escape it, then press R, so you will be back. So in this way you can control, and also if we are add to some information regarding information, just go to components, here is a add a sticky note, so you can add whatever text colors, like in blue colors, that in medium left, so font size is, it's a large, background you can change, like, okay, that's up to this. So simply we can add, I mean this is my first project.
Tahir,
Yes, please.
can you please do that part again where you added the poles and zeros and the maximum on the plot?
Yes, sorry.
Yes, can you
So,
delete them and can you do that again? I just didn't see
okay,
that.
yes, sorry.
Thank you.
So
Thank you.
I have deleted this basically graph. So now most important thing is that just right click on this, okay, and then go for graph meters, and then after that go for a graph or add overlay graph with signal. Okay, so this will be here, simple. And similarly, just for right click on this value and then graph and add overlay graph with signal. Okay, so this is just mean the x-axis, the values with respect to time, like the current changing with respect to time, and similarly the voltage. Now the most important thing is that how we can get the actual value. Just click on this arrow here, so where we can set sorry, I can drag here. here is an arrow, just click and then we can see the informations here, toggle markers. Otherwise we can press x-axis along, this is y-axis along, mean one with x and then one with y. And you can plot the same thing with your a single click by pressing the on the graph and then click on R, so it will be within range exactly. So now we need to basically zoom in and zoom out our graph. We can zoom at the given scale here, but the point is that if we press again, I want to get back signal, just press R. Now the thing is that I want to check the values, like I can add. Now I can click back and then it will be toggle. Now important, see here is a value. When I click on this value, and also I can first zoom, okay, this, and then again go back to this, sorry, this button and click on this one, and then it will be gone. I mean that button will be not available. That otherwise you can just press escape and you will be. And similarly for this, just press an R first, that will be in the range, and then here you can go for this toggle button. Okay, here all zeros and poles. And next important thing, you can, so why this data? Because I just told you that mean we are not just here we are not confirming our results, just we are highlighting the modeling, and we are getting the information regarding our project. Just need to increase the size of this. Okay, up to this, this is a very basic circuit. Just I want to show you that some basic principle. One principle is that how to overlay our signal on a graph. Okay, and next is that when we add a different multi ammeters and voltmeters, so the basic value is current and voltage. So from here we can increase our project towards the other value. For example, if I open one circuit in front of you just after saving my project, so here is a save project. Okay, so just I'm opening one workspace that I have shared already with you, that was RLC. Okay, that I have saved with the different name like case 2. So I am just for explanation, so you can see that there is only one single circuit, that is a source with R and L. This is RL circuit. Now informations are only two information as important, the voltage and the current. Now with that voltage and current I have done all this work. Okay, now most important thing is that I can I have missed this channel, I can open this file. Okay, other than open, just go to open and then import. I have shown this advantage of making import. Just if you click on import, then you can open all version files like up to 4.1 and 4.2. Otherwise if you open only or direct open, that will be, you can open only 4.5 file. So it means some file if I have saved in my previous versions, I can use this, make use of this file by using import. So if this is RLC, so no, so okay, now everything that I have loaded, so here it's available here. So one by one, just right click on this and then unload your project, so that will be unloaded. So like in my first project, that will be, if I want to unload this, just unload this project. So now this is the RLC project. So important thing is that I want to show you that there the basic inputs are the constants, remain constant, because the only current and voltage. Now what we will see and at the output terminal, just I want to show some information. So I think everyone is okay with that simple modeling, like RL modeling with simple detail, that we need to extract only current and voltage from the circuit. Okay, I think I hope all of you there. Okay,
Yeah, that's fine, Tahir.
okay, yes. So next, we are moving towards the next step. If we are interested in generating more information from this simple circuits by making use of different logics, so we can create, we can generate. So simple. So one thing is that, like in this circuit, so first one is that I have labeled this, this is EA. One thing is clear, that if we are using the RL circuit without ground, then we can make use of this meter, like this voltmeter, like this one without ground. Otherwise there will be a dimension error. If there is a ground, then we can place this voltmeter to ground similarly. And then IA is within the series. There will be, there no, there should be no no shortage of line with the emitter, so emitter must be in series with that. Okay, once that is okay, so here you can see informations are available in these two channels. So now these channel through data levels move towards other value, like here posted E is here, IA is there, so here is a multiplier. Okay, where I can find multiplier, just if right click on this and then click F help F1, so you can find this F1 under the CSMM overview. So sometimes people uh, don't know about the main library, like in under master library, just under the main tab, and then you can see there is a multiplier under CSMF here. So just go to there, and you can see the initial, the first one is the multiplier is there. So in this way you can find this multiplier. Here you can see just a real multiplication, and then you will get this instantaneous power, because the instantaneous voltage and current multiplied, that is a PA. So instantaneous power is represented by PA. So mean three things are common. The one is label, another is channel, and other is the the graph that we will see. So here you can see the title is given, that is instantaneous power is available here. Okay, so mean I can basically plot this instantaneous power also. Okay, after that I can add a, basically you can say I am interested in the low pass filters, so added this, so I will get the average. Basically I have taken the average power of this overall throughout the you can say span of that power, instant power. So that power will be imported to another graph, we can connect together. Okay, I mean within the same graph you can see average power and uh, the basically instantaneous power is given. Okay, next important thing is that if I want to measure the reactive power of my system, so for reactive powers, so I know that the Q is equal to VI sine theta, and then the real power is equal to P is equal to VI cos theta. Okay, for that purpose I need magnitude and phase of my value, all value that is given continuous analog signal. So for that purpose I'm using, making use of Fourier transform, converting to the digital and getting magnitude and this phasor. So again this, where this available, just under the you can see that component available in the description, and if you are not just click on help and you will see the fast Fourier transform under the same CSMF. So in this way you can directly find the different fast Fourier transform components. Okay, and the most important thing is that what are the parameters. There is single phase, that is 60 Hz, and harmonics, that's fine, but the important thing is the output. The output must be in a root mean square, and then unit must be radian and the sine wave. Okay, and then anti-aliasing filter, that is used in the sampling of our output. When we sample our output, so some information are basically overlap our signal with the you can say the, because in, if you know the communication, we do the quantization and the sampling, so to make a get the full extract full information, like anti-aliasing is just kind of a filter in HVDC, so we add this one also. So after that we get make this use of this data tab, and we can get output here. Just place a data tab here and give the name to this, and you will get the same value. Okay, so in order to get a value from output from the block, and then need to fed that value to other components, we can make use of these data tabs similarly. Okay, once then data tab, again this is for current and this is for EA. So here you can see that the phase of this and this phase of current, then we difference, make a difference, then we get an angle, then angle goes to cos angle, then cos angle we can get this. Mean why we added data label? So it means that we can cause of that angle we can measure. Where data label is available, we can measure those value. Okay, goes to this one and this and click on this. So it means the average calculated value. Okay, so mean that very the p average calculation. Okay, next, if this value mean the magnitude and then magnitude simply and then sign of this, you can say this is a sine and then here, so you will get the Q calculated, you can say the average reactive power. So in this way, by making use of these blocks, so just follow mean same things can be done in the designing of the generator, exciters, all these things. We need to basically model exciter as a block, and then we add different parameters and like multiplication and addition and integrator or differentiator, then we get the correct output, and then we can make that component as exciter. So same thing is happening here. Just okay, see, if I run my case, okay, go to home and then run my case. Okay, let's see what happened. Okay, now you can see there is information available in under the P average and P instantaneous. Next important thing is that just click on here, or otherwise other than this, if just click and press R, so there are different values available. You can change the color traces, like here I think so. Yeah, okay, you can check this one, and if this is unchecked, so there will be no P average, only the instantaneous power, otherwise that both informations will be appear. Okay, and next here also the information regarding, oh, sorry, yes, next we can check this one also, if only the average power, otherwise the instantaneous power is also there. And similarly, in order to zoom and get the correct information, just press on the graph and click on R, so mean that will be the range. If we interested in the X, then we can press an X. Similarly, this will be X. If once you have done press R, then you cannot basically make changes, so because that is a perfect range that is given. Okay, the exact value of this is given here, so that component. So most important thing, if you are is looking for the units, so I can show you here. So mean we have added the maximum display input, so we can change here also. Okay, we can make use of these information, mean the voltage and current, and then we can extract information using the calculations and formulations of different, but make sure that the component that you have placed, the correct input must be done, clear. Like here in phase current is here using data tab, so that the same name must be here. Okay, so that will mean considered as the input. If we change any different name, so this is a simple circuit, so that will take a wrong input and case will not simulated, and in this way you will face an error in the simulation. And for that purpose, like if I change one name, like here I say IA1, okay, and then now run my case. See, one error is here, so I say where is the error? So he said input port is floating, a signal source must be provided. So I said I have provided, but this kind of variable is not initialized in my throughout simulation. Just copy this name and then paste it here. So label name and the output channel name and whatever, so input